One of the most active volcanoes in the world sits just a few hundred miles off the U.S. West Coast, and some scientists believe that it's really only a matter of time before it erupts again.
Deep beneath the Pacific Ocean, about 300 miles off the coast of Oregon, something massive is stirring. Hidden under nearly a mile of cold, crushing seawater lies one of the most closely watched volcanoes on Earth, Axial Seamount. And right now, scientists are watching it very carefully, because the volcano is swelling again, and it may be closer to eruption than expected. Axial Seamount doesn't look like the towering peaks we imagine when we think of volcanoes. You won't see smoke plumes or glowing lava rivers from the shore. But make no mistake, this is a giant. It rises nearly 3,600 feet above the seafloor. Its summit contains a massive caldera, nearly 2 miles wide. Vast lava flows from past eruptions stretch across the ocean bottom for miles. And unlike many volcanoes, Axial sits directly on a tectonic spreading center, the Juan de Fuca Ridge. This is where two tectonic plates slowly pull apart, and magma constantly rises to fill the gap. Axial doesn't sleep, it breathes. For decades, scientists noticed something remarkable about this volcano. It followed a pattern. Magma would slowly accumulate beneath the surface. The seafloor would rise, sometimes by several feet over years. Pressure would build steadily. Then, once it reached a critical threshold, the volcano would erupt. The pressure would release. The ground would sink, and the cycle would begin again. 1998, 1999, 2000. Each eruption followed roughly the same inflation pattern. In fact, before the 2015 eruption, researchers accurately forecasted that Axial would erupt before the end of the year. And it did. That level of predictability is almost unheard of in volcanology. So what's happening now? Recent monitoring shows that Axial is inflating again and approaching the same pressure levels seen before past eruptions. The seafloor is rising. Micro-earthquakes are increasing. Magma is accumulating. But here's the important part. This isn't panic, it's process. Axial Seamount is one of the most heavily instrumented submarine volcanoes in the world. It's monitored by seafloor pressure sensors, seismometers, deformation instruments, and underwater observatories connected by fiber optic cable. Scientists are not guessing, they're measuring. And here's what the data suggests. Axial is likely heading toward another eruption, but that doesn't mean catastrophe. Unlike explosive volcanoes such as Mount St. Helens, Axial's eruptions are typically effusive. That means lava flows, not massive ash clouds. When Axial erupts, magma usually pours out onto the seafloor in relatively contained flows. The immense pressure of the overlying ocean actually suppresses explosive behavior. No towering eruption columns, no continent-wide ash fallout, no apocalyptic shock waves racing toward the coast. Most eruptions at Axial happen quietly, in total darkness, far beneath the surface. But what about earthquakes? Axial sits offshore, while the Pacific Northwest's biggest seismic threat lies along the Cascadia subduction zone. This is the massive fault where the Juan de Fuca plate dives beneath North America, capable of producing magnitude 9 megathrust earthquakes. The last major Cascadia earthquake occurred in 1700. And yes, scientists know it will happen again someday. But here's what's crucial. Axial Seamount is not directly connected to the Cascadia subduction zone in a way that suggests one eruption could trigger a magnitude 9 megaquake. They are different systems operating under different tectonic mechanisms. Axial sits on a spreading ridge. Cascadia is a subduction boundary. The physics are not the same. Could seismic waves from large distant earthquakes influence volcanic systems? Yes. There is scientific evidence that very large earthquakes can sometimes slightly alter stress conditions in magma systems. But that does not mean one eruption triggers a regional chain reaction of volcanoes or megaquakes. There is currently no strong scientific evidence supporting a scenario where Axial's eruption would ignite the entire Cascade Range. Volcanic systems are complex, but they are not wired together like electrical circuits. What makes Axial important isn't that it's a doomsday device. It's that it's a natural laboratory because it's underwater, because it's accessible by deep-sea instruments, because it inflates and erupts in measurable cycles. Scientists can test eruption forecasting models here in ways impossible elsewhere. Axial is helping researchers understand how magma accumulates, how pressure builds, what signals precede eruption, how deformation predicts timing. Every inflation cycle improves forecasting methods, not just for submarine volcanoes, but potentially for dangerous ones on land. So what happens if Axial erupts in the near future? Based on past events, here's what we'd expect. A swarm of earthquakes beneath the sea floor, lava flows spreading across the ocean bottom, possible temporary disruption to seafloor instruments, some hydrothermal vent changes. That's it. No Pacific-wide tsunami, no coastal destruction, no immediate threat to cities. The eruption would likely go completely unnoticed by the public, except for scientific headlines. Now, could things ever be different? Science always leaves room for uncertainty. Nature does not sign contracts, but the best available data suggests Axial behaves consistently with mid-ocean ridge volcanoes worldwide, and those eruptions are typically non-explosive and localized. It's important to separate dramatic storytelling from geological reality, because fear spreads faster than magma. There is something fascinating, though. Axial demonstrates how interconnected Earth systems can be, not in a Hollywood sense, but in subtle, measurable ways. Large earthquakes can send seismic waves across the planet. Those waves can momentarily disturb magma systems. Pressure fields shift. Tiny fractures open. Fluids move. Earth is dynamic. But dynamic does not mean apocalyptic. The real story isn't impending catastrophe. It's scientific capability. For the first time in human history, we can watch a volcano inflate in real time, mile beneath the ocean surface. We can measure seafloor rise down to centimeters. We can detect magma movement through seismic signatures. We can model eruption thresholds with increasing accuracy. Axial isn't a mystery. It's a monitored experiment unfolding in slow motion. And here's the deeper takeaway. Volcano prediction is improving. In 2015, scientists successfully forecasted Axial's eruption window using deformation data. That success matters, because improving prediction at relatively safe submarine systems builds knowledge that could one day help communities living near more dangerous volcanoes. Axial isn't a ticking bomb, it's a teacher. Meanwhile, the real long-term seismic risk in the Pacific Northwest remains the Cascadia subduction zone, independent of Axial. That megathrust fault will eventually rupture again, but its timing is governed by tectonic plate motion over centuries, not by one submarine eruption offshore. Preparation for Cascadia involves infrastructure resilience, tsunami planning, and building codes. It does not hinge on Axial's inflation cycle. So what's happening right now? Axial Seamount is inflating. Pressure is building. Scientists are watching. And at some point, whether months or a few years from now, it will likely erupt again, quietly, underwater, in darkness. And when it does, researchers will gather invaluable data. The ocean floor will crack. Lava will spill. The seafloor will reshape itself. Then the volcano will reset, and the cycle will begin again. Not as an omen, not as a warning of continental collapse, but as a reminder. Earth is alive, and we are finally learning how to listen.